Every packet that leaves your machine starts with a question. How do I turn this IP address into a MAC address? YARP for IPv4 and neighbor discovery for IPv6 exist to answer exactly that, bridging layer 3 to layer 2 on every local network. Switches forward frames by MAC, not IP. So when a host wants to send a packet across the LAN, it must wrap the IP datagram inside an Ethernet frame addressed to the destination's hardware address. And to build that frame, it first needs to resolve the IP to a MAC. YARP solves this with a two-step handshake. The sender broadcasts an ARP request asking who owns the target IP. Every device on the segment hears it, and only the owner responds with a unicast ARP reply carrying its MAC. Both sides then store the mapping in their ARP cache. IPv6 retires ARP entirely and replaces it with ICMPv6 neighbor discovery. Instead of a broadcast, the host sends a neighbor solicitation to a multicast group scoped only to the target address. The owner answers with a unicast neighbor advertisement containing its MAC. Same goal, smarter delivery. Every entry in the neighbor table has a state managed by the neighbor unreachability detection state machine. Reachable means fresh confirmation. Stale means the entry is old but usable. Delay forces a short wait. Probe actively retransmits solicitations. And failed means the neighbor is gone. The legacy ARP command is obsolete. Modern systems use neigh, which shows IPv4 and IPv6 entries in a single unified view with a NUD state column. Adding IPS neigh exposes drop and confirmation statistics for troubleshooting reachability issues. Pulling it all together, neighbor solicitation packets fly across the wire, neighbor advertisements come back, and the kernel quietly writes the resulting mappings into the neighbor cache. IP neigh is your window into that cache, the single source of truth for IP to MAC resolution on a modern host. In this walkthrough we'll explore the Linux neighbor table, the kernel's IPv4 and IPv6 equivalent of the ARP cache. Using the IP neigh command family, all commands will target the loopback interface, so we can populate and flush entries safely without touching real network hardware. We start by clearing the terminal to give ourselves a clean canvas. The clear command sends an ANSI escape sequence that scrolls the visible region down. It doesn't delete scrollback history, so previous commands remain recallable with the up arrow. Now we run the IP neigh command to display the current contents of the neighbor table. On most systems the table is empty by default, showing just the column headers, address, device, and interface state. For comparison, the legacy ARP command shows only IPv4 entries in the older format. This is the classic view many admins grew up with, same underlying cache, different presentation. After another clear, we move into more precise queries. The IP neigh show command behaves identically to plain IP neigh. It simply makes the intention explicit and supports additional qualifiers on devices, protocols, and states. Filtering by interface with dev low limits the dump to only loopback neighbors. Useful when you want to focus on a single device. Here we see the IPv4 and IPv6 loopback entries with their placeholder MAC addresses in the reachable state. The S flag adds statistics columns, number of probes sent, failures, and the last update timestamp. Piping through head truncates the output for readability. On a real system the table is typically short anyway. Now we populate the table. Ping, C1127.0.0. .1 sends a single ICMP echo to the loopback address, which forces the kernel to resolve and install a neighbor entry. After the ping, the table now contains a fresh reachable record for 127.0.0.1 on low. The kernel may also create a 0.0.0.0 placeholder entry for the unspec destination on some configurations. Finally, IP neigh flush dev low wipes every neighbor entry on the loopback interface, a clean reset for the cache.